Hi there, this is Mrs. Meek, and once again we're going to move on in our chemistry and biology unit, talking today about chemical reactions. All right, so chemical reaction is any process in which atoms or groups of atoms are reorganized into different substances. And there are some clues that a chemical reaction has taken place. Some clues may be the production of heat or light, the formation of a gas, liquid, or solid. All right, so some of them could be more obvious than others. All chemical reactions allow living things to grow, develop, reproduce, and adapt. So there's all kinds of chemical reactions occurring in your body and occurring in all living things in order to carry out normal life functions. All right, a chemical equation is a formula that describes the substances in the reaction, and then there are arrows that point to the products, which is what happens or what the result of that reaction is going to create. So the reactants are the starting substance, and they're always found on the left side of the arrow. All right, so the reactants are over here on the left side of the arrow, and then on the right side we have the products. All right, so that is the substances that are formed after the reaction occurs. Very simplistic, all right, but we need to remember this important concept that when we show reactions, we have to show balanced equations. All right, so according to the conservation of mass, matter cannot be created or destroyed. Therefore, all equations must show this balance of mass. And what we mean by that is if we have 6 carbons on the left side of our equation, we also have to have 6 carbons on the right side of our equation. We cannot lose any matter. All right, so the next important thing we need to talk about when we're talking about equations is the energy of reactions. All right, so when a reaction occurs, this is showing you an energy diagram. All right, notice X and Y are the reactants, and then the product is XY. So reactants are X plus Y, going to result in XY. All right, so this side of your graph shows you the amount of energy required. All right, almost every chemical reaction, especially the ones that occur in your body, requires some kind of activation energy. We need a little bit of energy put into the system to get the system going. So that is exactly what it is. It's the minimum amount of energy needed for the reactants to form products in a chemical reaction. All right. So when we're looking at this energy diagram, all right, this represents, all right, because here are the reactants, this is the amount of energy that needs to be put into the system in order to get the reaction to occur. All right, so we can have 2 types of overall reactions. We can have reactions that release energy, typically in the form of heat or light, or we can have reactions that absorb energy. All right, so the first type of reaction is an exothermic reaction. An exothermic reaction is a reaction in which energy is released. So we still have to add some activation energy in order to get the process going. All right, but when the products are formed, all right, notice that the amount of energy required for the product is much lower than that of the reactants, therefore energy is released. All right, so typically we will see heat or light in an exothermic reaction. And all right, so in an endothermic reaction, all right, notice here we have our reactants, XY. We still have to add some energy to get the reaction going, so this is our activation energy. But our products over here, X plus Y, all right, the energy for the products is greater than the energy for the reactants. All right, so this energy diagram is showing an endothermic reaction in which the energy of the reactants is less than that of the products. Therefore, energy is absorbed. All right, so the products have more energy than the reactants. All right, so therefore energy is absorbed. And oftentimes, if you're carrying out a chemical reaction in a beaker, you'll notice that that turns cold. It's because it's absorbing energy. All right, enzymes. Enzymes are really, really important when we start talking about biological processes, because enzymes ensure that biological processes occur. So almost every chemical reaction that is occurring in your body requires some kind of enzyme. So very simply, enzymes are biological catalysts that speed up the rate of a chemical reaction, and they are basically the chemical workers in the cell. Almost every reaction that occurs in your body requires some kind of enzyme. So if you remember, a catalyst is a substance that essentially lowers the amount of activation energy needed to start that chemical reaction. So if you look at the energy diagram, all right, with the addition of an enzyme, notice we almost, according to this energy diagram, we need almost half the amount of activation energy. All right, the catalyst doesn't get used up. It doesn't become part of the reactants or the products. All right, the catalyst just helps to get the ball rolling by lowering that activation energy. So a catalyst or an enzyme can be used over and over again. And it does not increase or decrease the amount of product that's made. All it does is lower the amount of activation energy necessary to get the ball rolling. All right, so that way these reactions can occur a little bit faster. All right, so let's look at the mechanism of an enzyme. All right, so the different parts of an enzyme, we have our substrates. Those are the reactants that bind to the enzyme at specific activation sites. So what an enzyme does is pretty much it helps the two reactants get close together, so that way it ensures a chemical reaction occurs. So rather than these substrates kind of floating around and trying to find where they need to bond, all right, the enzyme provides a very specific puzzle-like fit where those two substrates connect, and that'll determine, and that'll be exactly where those two substrates need to react in order to form that chemical reaction. All right, so an enzyme really just helps to ensure that that chemical reaction occurs much faster, and it makes it easier for the reaction to occur. So what happens here, we have our two substrates. So this may be X and this may be Y. They bind to the enzyme, and then they're in the perfect location where they need to undergo their where they need to undergo the reaction. All right, and then that can be released. Okay, at the end, notice here's your product. So a little bit of this molecule was cleaved off and bonded with this part of the substrate. All right, and we form two different products in this one. Sometimes we form one product, so it would be the entire substrate, or it would be the two substrates would just bind completely together. It kind of depends on the reaction that we're looking at. All right, notice the enzyme is not part of the substrates at the end. All right, the enzyme is left basically in the same status. It's the same shape. It's got the same chemical makeup. All right, all it serves is really as a platform that allows the two substrates to be in close connection with each other to allow that chemical reaction to occur. All right, so the specific location where these substrates bind is called an active site. All right, so the substrates bind to the active site, and they bind there in a very puzzle-like fit. All right, and allows the substrate complex, it allows the chemical bonds to be broken down and create the new bonds rather quickly. All right, so it just ensures that they're in the perfect orientation to allow that chemical reaction to occur at its quickest. All right, so there are a lot of factors that can actually influence enzymes. pH, all right, we haven't talked much about pH yet. We're going to get to that next section. But if you remember, the pH is how acidic or how basic, all right, the environment is. Other things that can affect how well an enzyme performs is the temperature. Some enzymes perform better at cooler temperatures. Some enzymes perform better at warmer temperatures. If you think about the temperature of your body, most of the enzymes that are necessary in your body perform better at what your normal body temperature would be. All right, and other factors can also affect enzyme activity. So in your body, a temperature close to 37 degrees Celsius is where most of the enzymes are going to perform at their peak. All right, just to give you an indication of some of the enzymes that are in your body, this is just a few. All right, and notice all enzymes pretty much end in this ASE, this ACE. All right, so enzymes are easy to determine when you're looking at or when you're reading in a biology textbook, because almost always they end in the suffix ase, A-S-E. All right, so lipase, all right, splits fats, which are often called lipids, and these digestive enzymes are in your stomach. Maltase splits the sugar maltose, and that is in your small intestine. Pepsin, okay, now notice we've broke format here. Pepsin doesn't have that ASE at the end, but it splits proteins, which are often sometimes called peptides. All right, and those are in your stomach. Renin is an enzyme. It's a manufactured enzyme, so there is a natural occurring enzyme in the stomach that can curdle milk. All right, but this is a more purified form. All right, and this is actually, if you decide to do the cheese making lab, which is a good follow-up to these notes, you'll use the actual enzyme renin. Lactase, all right, it splits milk. All right, we lost that on here, so let me get that back for you. But splits the sugar lactose, which is the sugar found in milk. And then we have protease, which actually splits proteins as well, and it is in your stomach and your digestive system. So pepsin is a specific protease which splits proteins. All right, that is just a few of the digestive enzymes in your body, but you technically have enzymes working all over in all different areas of your body. All right, so let's take a look real quick. There's a short video about enzymes. And I hope you enjoy it and have a
Enzymes enable molecules called substrates to undergo a chemical change to form new substances called products. Each enzyme acts on a specific molecule or set of molecules called substrates. Each substrate fits into an area of the enzyme called the active site. This fitting together is often compared to a lock and key mechanism. However, the enzyme changes shape a little to fit with the substrate. In the enzyme-substrate complex, the enzyme holds the substrate or substrates in a position where a reaction can occur easily. After reaction, the enzyme releases the products and can go on to carry out the same reaction again and again.